Hello everyone. In the last time we saw a box which is being rendered on a HTML page, and it has we can orbit, pan, pan and zoom uh, on this 3D rendered environment on the HTML page. So, and also if we change the size of the window, then the object itself is responsive. The rendered area responds to that. So in this time, what we are going to do is we are going to restructure the code a little bit, uh, make it more compact and cleaner and easier to maintain. Then after that, we are going to add some controls to this HTML page, which will allow the user to interact with this 3D object based on some numbers. So we basically parameterize the box, and it really shows the power of this this way of sharing our 3D creative ideas. So overall, what we are going to do is we will have a render loop that we saw last time. It's just going to render the scene and the camera. This render loop is controlled by infinite loop, which is constantly listening to various changes on the window size and the mouse action. So we have set up an event listener on the window, and as soon as there is a change, the infinite loop actually listens to the change, makes the adjustment, and then re-renders the scene. Uh, Now in this class, what we're going to do is we're going to set up an event listener on HTML element, and as soon as that event changes on the element, then it will call the draw function, which will then call the rendered loop, render loop. Okay, so let's get to it. This will be the third basic coding exercise or exploration. So it's 003. So first of all, let's set up some sliders on the scene. Um, we will also call it let's also put this 3D object inside a div that we can control instead of it randomly attaching to the bottom of the HTML that we have now. So by that, what I mean is right now we have document body.appendChild render.dom element, which means that whatever we have on the HTML page, the renderer will just attach itself to the bottom of the list. So let's make it more clear. So let's make a div with the ID of 3D, and here we can say that document. So let's say that document.get element by ID. So the ID is div 3D. Was it a capital or a small letter? That's fine. Uh, and then to this we can attach the child. So to this we just append this child here like this, and this should already work. Okay, so div id document dot get element by mm, oh, the problem is the script is running before we have declared the div. So please note that error here. Okay, so we are now rendering to that div 3D object. Next, what we do is let's set up three sliders. So let's have another div, and we will have an input. Type will be a range, and we'll have a minimum of 1, max of say 10, and its basic default value, let it also be say 3. What else? And let's give it a ID of width. Okay, so similarly we have a height, and a depth. We have that there, and just for clarity, let's do a label with height and depth. Now, what else do we need? Okay, let's, and just to be very clear, okay, so we'll have the length, width, and height. Maybe the equal to is not necessary here. Yeah, let's just keep it at this for now. Okay, so let's restructure the code a little bit. I'm going to make a function called init 3D, and the whole structure that we had outside, we just paste it into this init 3D function. So now we have only functions, and because and everything is inside of functions except for the variables of renderer, scene, camera, and controls, and it won't do anything because we're not calling the function. So let's just call the function here. So now we are calling the function, and everything else should remain the same. Okay, so we have this. Now let's see. We have we have already implemented the right hand side of it, event listener on HTML window. Let's implement the left hand side of this. So let's first of all set up event listeners on HTML elements. That we do here. So let's say document dot event by ID with dot add event listener, and let's just listen to any change, and then we will say, then just draw. So we need a function called draw here, and here let's just copy this. Let's width w is equal to document.get element by id width, and we take the value of this. We also need to make sure that it is a float. Float is a numerical type. Okay, so we have let w is equal to document.get element by id, which will be width, the value of that HTML element, and then convert it into a float, and then we'll say console.log w. So now if I refresh this page and if I make a change, okay, so it says 7, and you can see that. Okay, so if I change again and then leave 4, okay, so this is coming from this line 44 here. So similarly, let's just quickly do height and depth. Let's do height. Oh, sorry. So I'm just doing a control C, control V to reduce the possibility of making errors. So now WHT. So now whatever change we make, it will just print the WHND. So width, height, and depth. So next what we have to do is we need to render the object itself. Okay, so this object here, let's take all the elements that need to be rendered, axis and the box. Let's bring that down to this draw function. Okay, so in the init function we only set up the infrastructure, and it's only in draw function that we actually draw. And before we close out the init function, let's just draw it once. And once we finish drawing, let's call render. Okay. So now what happens is init function set up the event listener, calls draw. Okay, so actually init will also call draw directly once. Okay, so it's probably something like this. So init calls draw and it goes to render. And then we have in init we set up event listeners, which all the time they call draw if they find a change, and then that goes and renders. Okay, so it's straightforward. Now, how can we connect the mesh that we are generating here to this to these parameters? We can just scale the mesh based on the parameters mesh.scale.set w comma h comma d. Okay, we are getting some immediate results. And you can see that what's happening is when we increase it, it shows the change, but when we decrease it, it doesn't show the change. Basically, what is happening is it's a opaque surface, and when we make the dimension smaller, it doesn't show because it's inside the bigger box. So we can make sure to add some transparency. If we add some transparency, sorry, then we will be able to detect this change. So we set transparent to true, and then we need reduce the opacity. So let's make it 0.25. So this is the initial box which is rendered and with the default values of 3, 3, and 3. Okay. And now if we increase the width, you can see that there is a at the center there is the opacity keeps increasing right at the center, which means that there are more boxes being rendered at the center. Okay, so what we have to do at the beginning of this function is to uh, figure out some way of clearing the scene altogether. Okay, so there is more than one way to do it. My personal preferable way is to use a mesh array as a global variable that collects all the geometries or the meshes that are renderable to scene. And then I remove the mesh. So what we can also do is we can look at all the children elements of the scene object, and we can remove them, but actually that doesn't remove them from the memory. So so the best way is to I mean the only way is to dispose of the geometry and material, uh, which for which we need to collect all the objects that are rendered to screen. So here I've introduced a mesh array as a global variable, and what we will do is we will add this mesh to the mesh array dot mesh, and then we add the mesh array to the scene. So at present, this may seem to be a little bit excessive. We can just delete the mesh here. Uh, but when we have many objects that we will see eventually in this series, that's when this technique will be useful. Okay, scene dot add e. Okay, so so suppose we have a draw function and we are doing many things in the draw function, adding many objects. Then at the end, it collects it and it collects it in the mesh array, and then it adds it to the scene, which is then rendered. So actually, we probably don't need to call this render because the animation loop is anyway rendering constantly. But just to make sure that there's an instant change, I've called it. But probably we'll remove that uh, in the future. We'll see if that works that way. Okay, so now what we need to do is we still need to remove the uh, objects as soon as we before adding the objects. Before adding new objects, we need to remove the previous object. So that we can do by saying mesh array dot for each e. So e dot geometry dot dispose. Okay, so this will remove the geometry, and the other thing is material. So now we remove both the material and the geometry, and then we just clear out the array. So if we don't dispose of the geometry and material by issuing these commands, it will remain in memory and it will keep adding to the memory. So that's why we need to do it this way. And you can see that, is it working now? No, not yet. Okay, so mm, next what we do is, so let's say scene dot, so let's say while scene dot children dot length is greater than 0, then scene dot remove dot children 0. So we check if the scene has many children, and if it has, then we remove the first child. Then again we check if the scene has any remaining children, and then we remove that. So with this we ensure that all the objects are clearly disposed, and we also remove them from the scene. So I have a, yeah, with this we have achieved this parametric, and I want to see if it still works, because theoretically if we remove the render here it should still work, because yeah, it works. So we don't actually have to call render, because we this is actually not necessary because of this infinite loop. So draw, it is adding to the scene. The draw function adds objects to the scene, and then the infinite loop actually renders the scene and the camera together. So I can write it this way. No. So this is rendering to the, let me put a different color here. So draw is adding objects to the scene, and infinite loop looks at the scene before rendering. So we don't actually need a render after the draw object. Okay, so maybe uh, we can do something like this. So draw updates the scene, and then the infinite loop, as it looks at the scene, and then it renders it. So that's what we get here. Well, so pretty much that's how it works right now. Okay, let's uh let's do some curves in the next class. Thanks.